All right, today we're in section 5.2, rates and unit rates. Can anybody remind me, what did we learn about yesterday? What did we learn about yesterday? Hadley?
Ratios.
Yes, ratios and ratio tables, right? Ratios and ratio tables. Okay, and one of the most important parts of that lesson yesterday was finding the value of the ratio. You guys remember when we did that? We divided the first amount by the second amount. Okay, the first by the second. And when that happened, we found the value. Today, we're going to call that something different. Okay, but we're essentially going to do the same thing. But now today, we're going to call it a unit rate. All right, but before we do that, I just want to review what we did yesterday. And that is to complete the ratio table using equivalent fractions. Basically, all that means is we're going to use the same value. All right, that's the value. The value, using the same value across the entire table, ensures that I have equivalent fractions. So you don't have to use fractions in the table. Okay, does that make sense? It's going to be decimal values, or you could say it as a fraction. Either one is fine. All right, so find the value and then complete the table. Go ahead and do that, please. What is the value? Just tell me. 2.5. If you wrote it as a fraction, that's fine. 2.5 all the way across. And if we're going from the top value to the bottom value, do we multiply or divide? Top to bottom.
Top to bottom divide.
I divide. Very good. What's 18 divided by 2.5?
It is 7.5.
Okay. 7 point. It's not 7.5. 7.2 or 7 1/5. Okay. What's 6 times 2.5? Should be 15. Should be 15. What's 22.5 divided by 2.5? 9. Okay. So this here, okay, this is my completed ratio table. You definitely will see this on a quiz or a test where I say complete the ratio table. Okay. Now, on your homework, what you saw was this middle section actually did not exist. But what I need you to remember, and this is what you're going to see on your quiz and your test too, that doesn't change the fact that you still have to know the value. So, and I probably should have clarified that a little bit better yesterday. That box wasn't there on your homework assignment, but you still had to find the value so you could go back and forth, okay, and fill it in. Does that make sense, guys?
Yes.
Does that make sense? Okay, so I added in that box to help you guys learn that. In order to find the equivalent fractions, you had to have a value of the ratio. Okay? All right, so today you're going to see so many similarities between today's lesson and yesterday's lesson. One key difference is that a rate is still a ratio. It is a kind of ratio. Now, remember what I said yesterday. A ratio has to be a comparison of two quantities in the same unit. Remember when I gave you that bike example? I rode 6 miles on my bike versus 6 feet on my bike. That's not the same thing. You guys remember that from yesterday? Yeah. Okay. So a ratio has to be in the same unit. A rate is a comparison using different units. That's the difference between a ratio and a rate. They are both comparison of two quantities, but a rate is in different units. You see an example right here. All right, you can stick with the bike example. I rode 16 miles in 4 hours. 16 miles in 4 hours. Then you see a unit rate compares a quantity to 1 unit of another quantity. The denominator must be 1. So we see actually the same rate from the first example, but now my denominator is 1. So if it's 16 miles in 4 hours, it would be 4 miles in 1 hour. I'll show you in a minute how we're going to solve for that. Then in the last example today, we're going to talk about equivalent rates. Equivalent rates have the same unit rate. And again, this will make more sense when we get to that example, all right? So just fill in your terms for now, and we'll fill in the missing pieces in the examples. All right, so example 1. Okay, here's my scenario. A nutrition label shows that every quarter cup of tuna has a half a gram of fat. All right, so here's my first question. How many grams of fat are there for every cup of tuna? So here in my example, I have a rate, okay? I have a rate. The rate, though, doesn't mean that it gives me the unit. Every 1 cup of tuna. That's what it means by every cup. So here's how I find the unit rate. I must compare or divide the first quantity by the second quantity. All right, so what was my value for the grams of fat back up in the example? How many grams of fat was it?
1/2.
1/2, okay. So I have 1/2, and in order to find the unit rate per 1, I must divide it by the second value. How much tuna? 1/4. Okay, you're going to see a really strong similarity to the value of the ratio that we did yesterday. That's exactly what we're doing today. We're just calling it unit rate. 1/2 now multiplied by 4/1. I had to flip that second fraction. I get 2. Okay, now for unit rate, anytime I'm talking about rates, a number without a label is actually an incorrect answer because 2 of what? 2 of what? The label is just as important as the number. So it is 2 grams of fat per cup of tuna. 2 grams of fat per cup of tuna. Okay, do you see how I did that? And now that makes sense, but without the label, it really didn't make sense. It just said 2. Well, 2 of what? Okay. All right, so now let's look at B. It says now how many cups of tuna are there for every gram of fat? So you see, guys, this second value is the one we're finding the unit. That's why it's so important to get the order right. Okay, so now how do you think my ratio or my rate is going to change compared to the first one? Can anybody tell me what my new rate would be, Hadley?
1/4 divided by 1/2.
Exactly. 1/4 now divided by 1/2. I had to reverse the order because in my statement the order was reversed. Okay? So now I have 1/4 times 2/1, which would be 2/4, which is what, guys? Now you come up with the label. You come up with the label. Again, half of what? Without the label, my answer does not make sense. What it is, Hannah?
1/2 cup of tuna for every gram of fat.
Perfect. 1/2 cup of tuna for every gram of fat. All right, gram of fat. All right, great job, guys. So now I want you to do one on your own. This is a different scenario. There's a 1/4 gram of fat for every 1/3 tablespoon of powdered peanut butter. Okay, so now answer this question. How many grams of fat are there for every tablespoon of the powder? Okay, so it told me in the scenario 1/3, but I know what I need to do to these values to find the amount of 1, the unit rate. Okay, so did you go 1/4 divided by 1/3?
Yeah.
Okay, flip the 1/3, and it was 3/4 grams of fat per tablespoon of peanut butter. All right, how many got that right? Okay, all right. Okay. All right, next problem. Okay, so now we're going to find the unit rate again. Guys, it's just a lot of the same practice just to find this unit rate. And unless it's otherwise specified, okay, so here's where we're going to have to flip a couple pages. Like I told you at the beginning, the printing got messed up on the order. Okay, unless it's otherwise specified, the second unit will be the one in the denominator that I'm finding 1 of. Okay, All right, so here we go on this one. It says $1.32 for 12 ounces. Say 12 ounces of macaroni noodles or something. And we'll talk in a minute on how this can actually be pretty applicable to our everyday, actually what we do, at least on a weekly basis. Okay. All right, so we have $1.32 for 12 ounces. It says find the unit rate. So what I'm trying to do is I'm trying to find the value or how much money per 1 ounce. How do I do that? I take the first value and I divide it by the second value, $1.32 divided by 12. You will be allowed to use calculators on this test, okay? However, think about it. $1.32, 132 divided by 12. Okay, and then put in your decimals. Okay, you might be able to do that mental math. $1.32. You can use your calculators to double check. $1.32 divided by 12. Then 2 decimals in your answer. Samuel, how much?
11 cents.
11 cents per ounce. Next time you go to the grocery store, okay, and you're like kind of in some of those boxed goods area, or even if it's like packs of gummies or anything that has a weight to it, okay, I want you to look at the price tag. It's going to give you a price, okay, but then in the corner, it's going to tell you how much per ounce. If you look at that, all right, is anybody's parents like a member at Costco or Sam's? Anybody? Okay, so we know that buying in bulk, all right, when we buy in bulk, we actually pay less money per ounce or per item, and that's why buying in bulk saves us money. It actually gives us that information on the price tag. Next time you're in the grocery store, look, I promise you it'll say like 32 cents per ounce, especially for like drinks. Okay, it'll do that, and you know how much you're spending on your Starbucks, you know, cold drink that you get in the refrigerated section. All right, look at B. 1/4 gallon for every 3/10 of a mile. So this is great. Yeah, this rate tells me how much for every 3/10 of a mile. But in order to find the unit rate, I must follow my process. 1/4 divided by 3/10. Okay, so there's my rate, but to find my unit rate, I must divide. Go ahead and finish that one and include your label, please. All right, so we flip 3/10, 10/3, multiply, and I got 5-6 gallons per mile. So think about it, okay? Now I know how much per mile. Aiden?
Didn't you have cross-reduced?
Absolutely, I could have. Yep. Yeah, he said I cross-reduced right here to 2 and 5, okay? And then 2 times 3 is 6. You still get 5 over 6. Either way is fine, okay? Totally fine. But now, okay, so if I have 1 gallon of gas, can I make it the whole mile? Okay. Did you know this is terrible gas mileage? Usually, like a vehicle gets 20 miles a gallon. This gets 1. So this is like an army tank or something, okay? All right, even an RV gets like 5 miles a gallon. Yeah, exactly. Okay. All right. So here we go. We're going to now use unit rate, but that's not the answer to this question. Let's look here. It says a scientist estimates that a jet of liquid iron in the Earth's core travels 9 feet every half hour. Okay, so they're pumping liquid iron out of the Earth's core. It's actually pretty interesting when you think about it. Travels 9 feet every half hour. How far does the liquid iron travel in one day? Well, in order to answer this question, I must first find my unit rate here up top. Okay, so find the unit rate. If it goes 9 feet every half hour, I want you to tell me how many feet in 1 hour. You do that by dividing. Okay, do that by dividing just like we've done in the earlier examples. 9 divided by 1/2. Okay, so we must find the unit rate first of the liquid iron, then we can use the unit rate to answer the question. And think about it. If I'm going 9 feet in a half an hour, how far is it going in 1 hour? Everybody figure it out? If it's traveling 9 feet in a half an hour, 9 divided by 1/2. Technically, the process is to divide the first quantity by the second quantity to find the unit rate. Well, that would mean to flip it. Okay? Doesn't that make sense? Think about it, guys. If it's going 9 feet in a half an hour, it's going to go 18 feet in an hour, right?
Yeah.
But that is not the answer to the question. What is it asking me?
How far does it
Your day.
How far in 1 day? How far in 1 day? So now we're using the unit rate. Okay? We figured out how much in 1 hour. Now how much in 1 day? Matthew?
432 feet.
Yes. 18 times 24. 432 feet per day. The label is important. Okay? The label is important. Feet per day. If all you say is 432, that means nothing. With unit rate, you have to tell me of what. All right, how do we do on that one, guys?
Great.
We do that okay on that? So we use the unit rate. All right, last thing. Now I need to compare rates. Now I want to know, are they the same value? Are they different values? This is really important when I'm making decisions on, okay, do I buy this item in bulk? Do I just buy it like per individual box over at Publix? Is it really a savings? You can compare equivalent rates, but in order to do that, you must look at, all right, this was back in your terms. You need to look at the unit rate. Guys, look up here for just a second. You can't look at these numbers right here and say, no, they're not equal. Look, that's a 20 and that's a 35, so those aren't the same number. That's not what it's asking. It's saying, are they the same rate? Are they equivalent rates? In order to figure that out, you must find their unit rate. 20 divided by 2 and 35 divided by 3.5. Because just like it doesn't look like it might be equivalent, it might actually be, right? So divide them. Find the unit rate. All right? If all you say is a yes or no on this, I can't give you credit. You have to show me. Have to show me, guys. All right, well, this is easy. What's 20 divided by 2? Okay? So the first one is 10 pounds per year. So if the second one is 10 pounds per year, then I'm good to go. What's 35 divided by 3.5? It's 10 again. 10 pounds per year again, so guess what? My answer is yes. So the sad thing is, on these questions, a lot of times I'll see students do all the work, but then they'll forget to say yes. And it's like, oh, you did all the work, but then you forgot to answer the question, so you still lose a point. Okay? So I can see that you know the answer, but still don't forget to say yes. Okay? Look at the second one now. Look at B. And I think this is the last question. I need to compare to see if these rates are equivalent. Okay? Now remember, rates are written in different units. However, why can I not compare the two of them accurately? There's a reason why. Maddie? One is minutes and one's hours. So if I were to find the unit rate, this actually is not accurate. Because the first one will say 7 miles per minute, and if I were to divide 420 by 3, I'm going to think it's 14 miles per hour, but then that's not the same unit that I'm comparing. Does that make sense? Okay, so I want you to make this note, because this is going to happen. You always want to convert the bigger unit to the smaller unit. So to shorten it up, convert the bigger unit to the smaller unit. When that happens, you don't have to mess with fractions. So which one is bigger, minutes or hours? Hours is bigger. Convert hours to minutes. Go ahead and do that. Okay, we always want to convert the bigger one to the smaller one. So that way we don't have to mess with like microscopic fractions. Like how much of an hour is 1 minute, okay? How many minutes are in 3 hours? 180. Okay, so 180 minutes. Now that I have comparable units, now I can set up my unit rates to see if these are equivalent. I know the first one, 7 miles in 1 minute per minute. Now I need to know, is this bottom one, if it is 7 miles per minute, then I'm good. Okay. 420 divided by 180. Has anybody gotten that yet? What was it? Yeah, that sounds right. It's about 2.3 as a decimal, 2.3 repeating. Okay. Miles. Oh, I wrote that wrong. It should have been... No, that's right. Miles per minute. Okay, so is that the same? Are those the same? So my answer, don't forget to write your answer. My answer is no. My answer is no. All right, so let me ask you this. If you're trying to catch the train to work, train A is going 7 miles per minute and train B is going 2.3 miles per minute, which train are you going to take if you're on a time crunch? You're going to take the faster one, okay? So when you're looking at rate, guys, a lot of times rate determines speed. And you're looking at the speed of something or the value of something, okay? So those are some common categories there. All right, so that should just about wrap it up for 4.2. Or not 4.2, 5.2.